So I think we want to just grab this again from the terrain. What the hell did I just copy? Copy this. Because I don't know if you can modify it on the fly. Maybe you can, maybe you can't. There's basically no overhead here, though, because we're just modifying a reference, so that's going to be okay. So a splat prototype is an array. So the 0, and we might want to like code it differently, right? But like 0 is flat ground. 1 is cliff ground, or cliff splat, or whatever. So the more the angle is 0, the more we want to paint the flat ground. And the more the angle is towards 90, the more we want to paint the upper. So what we can do is actually get something like, we can get a float, which is the cliffiness, which is the angle divided by 90. Right? So if we're at 90 degrees, this is going to return a 1. If we're at 0 degrees, it's going to return 0. So this is the cliffiness. So the ground is going to get painted the inverse of the cliffiness. And the second splat, I'm doing this wrong. Bear with me. I'll fix this in a second. Is going to get painted based on the absolute cliffiness. But this is not actually enough. What we need is not this. It's this dot. It's not this. It's, hold on. Terrain data dot get alpha maps. That's what we need. Hang on. We don't need the prototypes anymore. That's not what we need. Instead, what we need is we need a triple array like this of splat maps, which is terrain data dot get. It's alpha, actually. They're called splat prototypes, but then it's the alpha map. So we're going to get the alpha maps. We're going to get it for the whole thing. X and Y is this. The width is the terrain data dot alpha map width. And then the height is terrain data dot alpha map height. So we're going to get the full alpha maps. It's going to be a set of 3 arrays where this is the value X and Y coordinates followed by the index of the splat. Which is very well explained in the documentation. So the X and Y coordinates is AX, AY, and splat is 0. And then same thing here, AX, AY, splat 1, which is going to be set to the cliffiness value of 0 to 1. And then when this is done, you go terrain data dot set alpha map. It needs the XY offset, which is going to be 0, 0, and then it needs the maps to be fed back in. Probably this will work, except for one bug. There's one bug for sure. Fix me! There's probably going to be more than one, but there's one that I've intentionally left in. First, does it compile? I'm as shocked as you are. Hit play. No tragic errors. Did anything get painted red? Is this being called? It's always a good question. Does it have to get called after everything? I don't think so. Out of curiosity, set this to 0 and set this to 1. Let's make sure this is actually being run. And I probably just have a math error. Okay, it is running. It's painting everything red. Excellent. Now, is it possible that our map simply isn't cliffy enough? Well, let's force the issue by making our map quite a bit steeper over here. That value should really be in a variable somewhere. Okay, things are definitely reddish. Which is fine. Now, I think one of the most notable spots might be here in the crater. Let's take a look at this and see. I'm going to take the main camera. And I'm going to move it such that it's in the crater here. It'll have to get moved up again. And thanks for the great tip. I'm just going to copy the value from this component. I'm going to stop playing it. I'm going to paste the value into this component so it keeps those changes and hit play. Divisor, thank you very much. Integer division, probably over here. Thank you very much. That's not the bug that I was thinking about, but you're right. We're dividing integers, which means that this value will either have a value of 0 or 1 all the time, which means we're always sampling from the same location. Excellent. Okay. Now we have a map that is both yellow and red. You're going to be like, ah, good. So the cliffiness is working, except it's not. As we can actually probably see better from the camera view, there are areas that are flat and yellow, because my ground terrain is slightly yellowish, but these areas are pretty flat too, and they're kind of reddish. And if we look at the cliffs, there's some yellow bits and some red bits over there. It looks like a random number generator has decided what's yellow and what's red. But if we zoom out a bit, you can sort of maybe start to see a pattern emerge that makes a little bit of sense if actually if we were to flatten the world again and take a better look at things without shadows. Actually, if I just went and turned down the light, or I guess I'd have to increase the ambient light. The problem is this. Remember that our terrain has the X and Y coordinates inverted. So it's tilted. The diagonal axis that cuts the screen, I'm doing it right on me, but that cuts the screen this way, is mirrored, because the X and Y coordinate system of the terrain engine is flipped, which means there's a mismatch here between how we're painting our splats and how we're pulling the steepness. What we have to do is invert the X and Y somewhere along the way. So right here, note X and Y are flipped. If we do this, it should, I think this is the last bit of math that needs fixing. Now it looks right. Flat areas are kind of yellowish. Mountainy areas look reddish. And if we look at the camera view over here, flat areas are yellow. Cliff sides are red. And it'll look a lot better if instead of using the red, which I used just to make it more obvious what was going on, if I use the regular cliff terrain over here, then it starts to look significantly better over here. Well, depending on if I actually, chose the right textures and things like that. If we move forward along the Z over here, we can get up a little bit closer. Clearly things are still a little bit too pointy over here, and it doesn't look particularly realistic. That's mostly a question of let's retune the resolution and the scale of things, right? Things would actually look dramatically better since this, again, our texture, we are using the whole of the texture right now, right? Which is simulating the entirety of the lunar surface. But we're only rendering about a 1 kilometer square area, so it's actually not realistic for us to use the entirety of the texture. We can fix that, though. Yeah, let's go and trim this down here. And what we're going to do is we're going to let's zoom in to the middle of the image map. And we're going to do it thusly. We're going to take, say, one of our positions, X position, and we are going to say it's equal to its current position. We're going to make it maybe a quarter. No, we're going to make it a tenth of its previous size. Okay? 0.1f. So now instead of having X position go from 0 to 1, it's only going to go from 0 to 0.1. And we're going to add to that a value of, if we want it to be centered, I guess 0.45f. Because now it'll be, the X will actually range from 0.45 to 0.55. So an area, a tenth the size of the full width, right in the middle of the image. So we'll do the same thing with the Y over here. Now, this is actually something that you really want to farm out to some sort of rect function, right? You want to pass a rectangle here that defines what area of the map are we looking in. That can specify sort of zoom levels and all kinds of different things. We'll look into doing something like that after. I think this is correct. Probably. I don't know. Math is hard. If we hit play, and especially if we look over here and find our terrain, we are zoomed in considerably into some terrain area now. The terrain, the physical size in Unity is just as big. The resolution is the same as before, but we're focused on a much smaller part of the world. And so that's probably looking a lot more kind of reasonable-ish. Yeah, that kind of feels better. Now, what we can actually do is do something like look into the actual diameter of the moon and the resolution or the size of our image, right? We tend to refer to resolution as like total pixel size, right? Like what resolution is my monitor? It's 920 by 1080. But that's not truly the correct way to use resolution. Resolution would be more like I have this many pixels per centimeter on my screen or some inversion of that. And so anyway, but looking at all those, we could actually literally get our terrain here to be a perfect one-to-one representation of the lunar surface. I suspect that would be quite boring, and you know the features would be very, very, very spread out. Even in Kerbal Space Program, everything's about a tenth the normal size. But there we go. So now we have this. We're looking at a tiny part of the world right at the equator, which also means we don't have to worry about like weird stretching or anything like that, because at the equator it's mostly going to be a nice kind of square projection. But now we have that. So now we have the ability, especially if we start to generalize things out. Let's say we tune this instead to be something like public rect, not rect, viewing area, viewing rectangle. It's not, I don't know. And I mean, we could have it default to. I think this would, no, I guess that wouldn't happen by default. If we do this, right? X and Y coordinate and have this value be, I guess, a percentage of the base thing, but it could actually be dimensions. We could try alter different things for feeding it in. But for now, if we do that, and then here we say something like this modified by width plus this by left. Left is crossed out. What are we supposed to use instead? X min. Really? So yeah, no, that's right, isn't it? Multiply by width. So if we had a width of 0.1, it would multiply it there. And we say we want the top left corner to be 0.45. That would be correct. Stupid math. Why you gotta be you, math? I think that's right. So if we were to run this now with the default rectangle of 0, 0, 1, 1, we should get the full lunar surface. And we do. And then if we return this to the 0.45, 0.45, 0.1, 0.1, then we get the same zoomed in area as before. Alrighty then. Let's make it a little bigger because we can see a bit more detail and it's more exciting. If we did this and a quarter and a quarter, there we go. So we're only going to be looking at half the image centered around the middle. Oh yeah, see now it's a nice interesting map. Good. Without any of the weird stretching you get right at the poles. I think that looks swell. So this is the first step. Project Mighty Spud is going to involve a lot more, and it's going to involve so much math as we work our way towards swapping from a representation of a sphere, which apparently has to be quite a bit bigger actually, right, which makes sense. There we go. Right? When we switch from being in space and having the sphere representation, as you get closer and closer to the surface, at some point, we're going to want to switch things so that instead of rendering the sphere, we're rendering the terrain lined up perfectly so that the terrain is exactly where the sphere was in the bit that we're looking at. And we swap the two. And it's not going to be that simple because, of course, we can't rotate the terrain. And to keep ourselves sane, we're really going to want to make sure that, like, negative on the y-axis is straight down, which means actually what happens when we come in here and we decide to swap from the sphere to the terrain, we're actually going to move the camera. We're going to rotate the camera such that the angle is exactly the same with the terrain below us, but with the terrain being set to the 0, and oh my god, there's going to be so much crap. And then the harder part, though, the harder part is going to be to correctly, let's say we come down on the poles, right, and we're grabbing this area over here with all the weird stretching and distortion. We're no longer going to be able to use the direct get pixel bilinear, because we're going to have to swap, we're going to have to do all sorts of coordinate substitution or you know, alteration, because when we're coming down here, this is at this latitude and longitude, which needs to map to a particular UV coordinate of the texture, distorted by going from cylindrical projection to spherical projection. I'm super looking forward to it, you guys. It's not going to be hard at all. Because math is my strong suit. I will be uploading this project to a download site. I will also this time be attempting, I'm going to throw this up on GitHub and then try to do, I'll try to put releases on GitHub that matches with each episode. That might be a better way to do it. A lot of people have requested it so they can see exactly what lines get changed between each episode and things in a much more convenient fashion. So I will look into setting up something like that. You'll still just be able to download the whole project directly if you prefer to do that, but you'll also be able to track things on GitHub, assuming I do things correctly. So we'll see what goes. The Mighty Spud. Sorry, Quill. Yes, Mighty Spud, who got me started on all this. It should be a really interesting set of problems to solve. You know, it's just going to be a question. Once the math for the coordinate transformation is correct, it's going to be awesome. But getting there is going to be a little bit interesting and tricky. And really what we're going to be dealing with is we're going to be dealing with 4 different set of coordinates at any given time. 2 of them are unity space coordinates, like in, you know, the unity transform X, Y, and Z. But there's going to be 2 perspectives of it. One is going to be when you're in space. One of it's going to be on the ground, and the ability to transform from one to the other. The other set of coordinates will be the latitude of longitude, or maybe like an angle. We'll figure out, I mean, latitude and longitude is angles. Whether we use literal latitude and longitude, or we use some sort of rotation to represent our position on the sphere, right? Because you've got the sphere, and one way to describe where you are on the sphere is to say, start from, say, the North Pole or whatever, rotate down this many degrees, then over here, there we are on the sphere, you know, where that vector touches the surface. That's a way to describe it. So that's going to be the 3rd coordinate system. And the 4th one will be taking this and mapping it to a UV coordinate of a texture to grab the correct color information from our texture height map and putting that into our terrain, which is going to be, the terrain is basically going to be a flat plane that gets glued like this, except, and you know, so our character stands here on terrain, but remember, when we're in terrain mode, we actually have to move the camera and alter everything because the terrain has to be flat. And then as the character moves around, we're always moving around on flat terrain, but it's effectively what we're doing is rotating the world underneath the character. Then we're also going to have to do something where each patch of the terrain engine represents, you know, maybe 1 square kilometer of the planet. But as you get close to the edge, we're going to have to create a second terrain. And you keep walking in a third terrain, and so on and so forth. In fact, I think in practice, what we'll do is we'll probably at any given time have something like a patch of 9 terrains being rendered at any given time. The middle one is the one you're walking on, and as you cross that boundary, what we do is the terrain that's the furthest away, we're going to despawn that, create a new terrain over here, and each one of them has to be generated from the correct coordinate system. And we'll play with different sizes, like if we do a 9x9 area of terrain, how big should each of those terrain patches be? I was going to say something, oh, with the ones that are further away, we can render at a lower resolution. That's not true, because as we get closer, that has to be full resolution, and we're not going to rebuild the terrain. Luckily, the built-in Unity terrain engine, if it's far away, will automatically render it at a lower res, both the textures and the mesh, which is fantastic. The terrain system also, and this I think is it part of terrain or data? Oops. Set neighbors, there we go. You've got a function for terrain where you can pass it the left, top, right, and bottom neighbor, and it will use that to automatically do some stitching to give you seamless terrain transitions from one to the other. So Unity's already sort of considered this idea. So yeah, so when 2 terrains meet, you get a perfect seamless transition, and everything just looks like one hunk of ground the entire time, which is awesome. Hey, I want to give a big thanks to all the January Patreon supporters, and these Mike Check supporters: Yukothin, Snoopy TRB, Pavel Zdanov,
Zdanov, Dracion, Jan Torivel, Michael McClintock, Aaron Toibson, Craig Mortel, The Not So Evil Engineer, Julien Auger-Lafont, Marius Fieldvold, Speedy Savant, Steven Stager, Valiant Cakefiend, Wes Oldenbeving, Michael Knudsen, Jason Yanity, Stephen Bonnerman, Kale the Quick, Neil Blakey Milner, and everyone who has watched, shared, favorited, and subscribed to this series. Thank you very much.